unless there's an all-star in here. Does anybody know right away how to tackle number 4?
Tried it, but I don't think it's right.
Like I'll give you 2 bonus points.
What's your answer?
Tommy.
Do you do the common denominators?
No. That's how you would handle the rational part. I mean, it's a good guess, but I'm talking about we have to handle these absolute values.
Oh,
Lydia.
I don't know how to figure it out, but I know at the end it always is.
If you're simplifying an absolute value expression, when you take the absolute value of something, yes, it will always be positive, but that's not going to help me for solving. I'm gonna go with you don't remember, which is fine. I didn't think anybody would. So let you think about this logically. If I cover up that expression with my pencil, and I just have like the absolute value of something equals 1, what 2 possible numbers could be the absolute value of blank equals 1? Negative 1 and 1. So because there's really 2 possibilities for what this in here could simplify down to, we have 2 little mini equations that we have to write from here. One of which says, okay, maybe this expression will equal 1 already, and when we take the absolute value of that, obviously it will become 1. But the other one says this expression might equal negative 1. In which case, if that expression equals negative 1, you'll then take the absolute value of it, and as Lydia said, that would just make it positive 1 that way. So then we just solve both of these. Now, you can get a common denominator here. You don't have to. I can just add 1/3 to both sides. When I think about 1 plus 1/3, I'm going to think 3/3 plus 1/3. 3/3 plus 1/3 is how many thirds?
3/3 plus 1/3?
4 thirds.
I actually get the answer. Well,
And then multiply by 2 on both sides. 4 thirds times 2 is how many thirds? 8 thirds.
Wait, but so if the absolute value, or what do you call those things again?
Absolute value signs.
Oh, okay. How come they're on the left side, but then I have to go find a 1 and a negative 1? Like,
Think about
the same thing. Yeah.
Because I could be taking the absolute value of 1, so what's underneath my pencil could be a 1, or what's underneath my pencil could be a negative 1. So whatever that expression is, I leave it alone, and on one hand I set it equal to that positive number, and then on the other hand I set it equal to the opposite of that. And then on the next one, if I add 1/3 to both sides, I'm going to think to myself, negative 3/3 plus 1/3. Negative 3 plus 1 is negative 2/3. Multiply by 2, and I get x equals negative 4/3. On a side note for solving, obviously when you are taking a test, doing homework, all your work has to be shown. How can you check your answers on your calculator?
Plug it in.
Plug what in? Go, tell me what to do.
Plug in 8 thirds for x, and then it equals 1, that's right.
Okay, so you're literally checking the answers that you got. So 8 thirds divided by 2 minus 1/3 gives you 1. Absolute value of 1 is 1. Okay, so that's like your typical checking. I meant like, how could you solve this graphically?
Put it into y equals.
Right, put both sides into y equals. So on the...
Do they intersect?
Exactly.
Oh.
So on the one equation, I would hit absolute value signs, which if you guys don't know, it's under your math and number, and it's the first option. Absolute value of x divided by 2 minus 1/3. And then on the other side, 1. And what you'll see is obviously... I go zoom 6 just to make it negative 10 to 10. There's your absolute value function. Here's your line y equals 1. And wherever they intersect should be your 2 answers. How do you find where they intersect? What'd you say? Second trace, yep. Intersection is an option. And you just bring your cursor close to the first intersection and you just hit enter, enter, enter. And you get negative 1.3 repeating, which is what that one is. And then you'd redo that process, second trace, intersect again, and scroll over here. Enter, enter, enter.
If you only solve it graphically, how would you like did
You
draw
can't,
a
you
graph, or-
can't, you won't get credit.
Okay.
You have to do all this algebraically, and then I'm just giving you a way to check it.
Okay.
Okie doke? All right. Number 5 is actually easier because we lack fractions. The only thing that makes it maybe slightly harder is that you have to isolate the absolute value on, and get it all by itself, which is pretty straightforward. Add your 15 over. What do you think your next step is, Mike? What's that?
Divide 5 over.
Yep. Good. Oops. Nice. And once you have that absolute value isolated, this is where you branch off and you come up with your 2 mini equations. I'm probably going to run out of room, so I'm going to do it over here. Madeline, what would those 2 mini equations look like? I'm sorry, I can't hear you. What? Well, I'm not solving anything yet. I'm just kind of going through this step of branching and rewriting 2 separate equations, both of which will then have to be solved. All right, let me give you all a general, I explained the logic behind it over here. Now just let me give you the rule, because I know that that's probably better for some of you. When you're branching off, you keep one of these exactly the same. 1 minus 4x equals 3. The only thing I took off was the absolute value signs. When you do the other one, you always keep the expression the same. 1 minus 4x is not going to turn to 1 plus 4x. The expression in the absolute value will stay the same again. 1 minus 4x equals, but this time it would be negative 3. Does that make sense? Okay, so 1 exactly the same, 1 equaling the negative number. And then solve from there. So now we would subtract 1 from both sides. Divide by negative 4. And there's one solution, and then your other solution. When you branch off and write those 2 mini equations, that's handling the absolute value. So after that point, there are no more absolute value signs. Any questions on that? 6 and 7 should be pretty straightforward. They're both polynomial equations. 7 more specifically is what type of equation? What'd you say, Caroline? No? Caroline, no, right?
Or B.
I know, bean. I just feel funny.
Guess check.
That's it. But what kind of function is this? They're both polynomials. What do you call a polynomial whose highest exponent is a 2? Quadratic. So the quadratic, we have a lot more techniques. We could do factoring. We could do the quadratic formula.
Guess and check.
That would be factoring. That would be a method within the factoring.
Right.
Or completing the square. Those are the main 3 methods of solving a quadratic algebraically. With a polynomial function, really though, factoring's your only option. A general polynomial with a degree higher than 2. So on 6, given that it's a cubic polynomial, how many solutions do you expect? 3. So we're going to go with grouping, take out an x squared, take out a negative 4, And so, Brock, what are my two factors?
X squared minus 4 and x minus 4.
And what do you do from here?
Factor out the x squared minus 4.
Very good. Keep factoring. X plus 2, x minus 2. And with those three factors, you can see your three solutions when you tee it up. X equals negative 2, positive 2, and 4. Number 7 is not factorable. If I think real quickly, 2 times 1 is 2. There are no two numbers that multiply to get 2 that add to get negative 6. So guessing and checking to factor is not going to work. Splitting the middle term to factor is not going to work because it's not factorable. When it's not factorable, though, that doesn't mean it's not solvable. If it is factorable, do you guys know this? If it is factorable, your answers are just kind of nice, rational numbers. Whereas if it's not factorable, your answers are irrational, will probably be some crazy long decimal. So the quadratic formula, who knows it? Tell it to me, Lydia.
Negative b plus minus square root b squared minus 4ac divided by 4.
Raise your hand if you know you knew that by heart. All right, pretty
It's
good.
in my brain.
Yeah.
So negative b means the opposite of b. So my b is negative 6, so the opposite of b is 6. Plus or minus the square root. B squared. So if I take negative 6 and square it, that'll give me 36. That number there should always be positive because you're squaring something to get it. Minus 4 times a times c all over 4. 6 plus or minus square root of 36 minus 8 all over 4. Radicals need to be simplified. Make sure when you're doing these, you are writing the answer in simplest radical form. I'm probably not going to look at the decimal answer. I want an exact answer. The decimal is never exact with your rational numbers because you have to stop it at some point, which means you're cutting numbers off. Exact means radical form. So root 28 is root 4 root 7. So that'll turn that into 6 plus or minus 2 root 7 over 4. And then each of these coefficients share a factor with the denominator. What's that factor that they all share? 2. So we just reduced everything by 2. Now, kind of in light of the graphing conversation we had on that previous absolute value problem, on something like 7, you could type, obviously, your quadratic in as equation 1, and y equals 0 in as equation 2, which we know is just going to be the x-axis, right?
Yep.
So it kind of stands to reason why when you're solving quadratics, you look at where it crosses the x-axis. Does that make sense? Okay. Your homework.
Homework and school.
You always have a homework and a spiral on Fridays. Bean, can you do the honors? 1s, 3s, and 7s.
Why 3 numbers when we already have a spiral to do?
The spiral is 4 questions, one of which is
Because the way my honest answer, I think I'm going to get one of those points deducted.
a philosophical question.